All right, section 8.5. This is going to seem very similar to the previous sections. So we're still doing hypothesis testing, and we are still using the same sort of decision procedure and the same language. There's just one thing I want to point out that's new here, and then I want to dive right into an example. So far we haven't been worrying too much every time I draw that normal curve, right? I've sort of been drawing it and calling it good. And the central limit theorem tends to guarantee that this will happen when the sample size is bigger than 30. However, and I'm not going to dive into the mechanics of this, but we do have slightly different mechanics going on here with the standard deviation. So far, anything that was loosely normal would work fine, and anything that was actually strictly normal would work fine too. In this section, anything that's loosely normal is not going to cut it, and we're going to need things to be fully normally distributed. Most of the time they're just going to tell you, hey, this is normally distributed. Part of the reason I'm doing number 12 is they have a little question about that, so we'll get to that. But let's dive right into question 12. There's a lot of words here, and that happens on a lot of these. I would encourage you as you read these to, of course, read them carefully. But really, the thing that you're going to want to scan for first, your keywords here, are test the claim. Right, so that should set a little bell off in your brain when you read that. So use a 0.01 significance level to test the claim that. And after this, we should be getting the start of what we need to be doing. That the sample is from a population with a standard deviation equal to, okay, so there's the claim. Standard deviation equal to 28.866. Who knows where they got that from? But keep in mind the standard deviation symbol. Population standard deviation is this. It's a sigma, lowercase Greek s for standard deviation, but sigma is equal to 28.866. And really with that much, I can start, right? I can say the opposite claim would have to be that it is not equal to the same value, 28.866. This one with the equal sign becomes the null hypothesis, and this one without it becomes the alternative hypothesis. Now this is the point where I need to track back into the words here and find out about the sample, right? Because that's the next thing, is what's the sample? 100 randomly selected credit cards. So that's sample size right there. I've got a sample of 100. They have a mean of 47.6. Just like in confidence intervals, that's going to turn out we don't need the mean. We're dealing with the standard deviation here, but they supply them both, right? So the mean and the standard deviation. So the standard deviation of the sample is 33.5. So notice the standard deviation of the sample is not 28.866. And it's a reasonably big sample size of 100. But again, I don't know if that's quite convincing enough evidence to reject the null and say the standard deviation is not 28.866. That's what will let the number crunching decide for us. Say just how unlikely is it to get a sample like ours if the null is true. One other thing that's worth pointing out here is for once they have actually changed the significance level for us. You know, it's almost always 5% that defines usual versus unusual. This time they've knocked it all the way down to 1% and said now I need a sample that's in the outside the most extreme 1% before I'll reject the null. They're using a higher standard of proof here. But okay, so just keep that in mind as we move forward. And speaking of moving forward, we are ready to grab StatDisk. We have our null and our alternative hypotheses, and we know about the sample. So go ahead and fire up stat disk, and we need to go under analysis, hypothesis testing, and we need standard deviation, one sample. And yeah, okay. So again, what is the alternative hypothesis? Our alternative hypothesis was a not equals to. So population standard deviation is not equal to claimed standard deviation. Okay, that's already the one we want. The significance level here has changed to 1% rather than 5%. The claimed standard deviation was this 28.866. 28.866. The sample size was actually 100. I remember sample size was 100. Sample standard deviation was 33.5. And you ready for the big exciting conclusion? The p-value is 0.02442. With our typical 5% significance level, this would be an unusual sample and we would reject the null. However, they did redefine the significance level to be 1%. So based on that decision rule, this is not an unusual sample. Unusual sample. It's not unusual. Not unusual enough, anyway, for this decision procedure. Not an unusual sample, so we will fail to reject the null. I cannot reject the null, which means I cannot go with the alternative. So my sentence, again, that I write at the end needs to say something about standard deviations of credit card charges. Okay, so we're going to say we're failing to reject the null, so we're going to say there's no evidence. There's no evidence to reject the null. There's no evidence to reject that the standard deviation of cents portions of credit card charges portions of credit card charges no evidence to reject the standard deviation of cents of credit card charges is 28.866. They claimed it was 28.866. I can't tell that they're lying. Again, my standard deviation was different, but not different enough to say, hey, you're a liar. Okay. There's a follow-up question here. It says, if the amounts... So we're done with the hypothesis test, first of all. Let me say that. And let me say when you are doing your next at-home exam, there are 5 things that I will be grading you on with all of your hypothesis tests, whether they're about means or standard deviations or proportions. So the 5 things will be the null hypothesis, the alternative hypothesis, the p-value, the decision about the null, so reject the null or fail to reject the null, and the sentence. So all hypothesis test questions on the exam will be 10 points, and there'll be 2, 2, 2, 2, 2. Anyway, okay, so let's go on to answer their follow-up question. It says, if the amounts from 0 cents to 99 cents are all equally likely, is the requirement of a normal distribution satisfied? What does equally likely look like? From 0 to 99? Equally likely means equal probabilities, means that it looks kind of like, oops, missed it. Kind of like that. Equally likely, not normally distributed. So if they are indeed all equally likely, the requirement of a normal distribution is probably not satisfied. If so, or if not, how does that affect the conclusion? I'd say the conclusion is basically not valid. If this requirement here of normality is not met, we're in a garbage in, garbage out situation here. Right? We didn't have good data to start with, so any conclusions based on that bad data are just bad. Okay, I think you're ready for this homework. There are a few questions that give you data, and you'll just pick that that other option. Right? You'll go over to use data and type the data in. But other than that, I think the homework will not contain any surprises. So have fun on 8-5, and we'll see you on the flip side.